You put together your notes, Sam, and if I don't like it, I'll tell you, okay? All right. There's one thing that's not new today, and that's parabolas. You remember this form? We looked at this earlier in the year. This is Vertex form of a parabola. And so instead of just y equals a times x squared, which we start out with, we have a horizontal shift and a vertical shift. Can you tell me what is the horizontal shift of this parabola? H. What's the vertical shift of the parabola? So therefore the vertex is HK. Does this parabola go up and down or left and right? Up and down. Why? This y equals. Here is the other form. X equals a times y minus k quantity squared plus h. What is the vertical shift? K. And what is the horizontal shift? H. So the vertex stays the same, but in the previous one, you look on the inside for the horizontal shift. Here, the inside would be the vertical shift. So that's something you need to keep in mind. So sometimes people cut this section out and use it for notes on your test. Sure. Front and back. A shifted ellipse looks like this. So instead of just x squared on top and y squared on top, we have x minus h quantity squared and y minus k quantity squared. Now, what do you think the center is here? What's the horizontal shift? H. What's the vertical shift? Very good. Maybe you remember when we did circles in section 1.9. And a shifted hyperbola will look very similar. I won't write both equations down. They just switch the x and the y in each of these situations. What do you think the center is here? So another way to write this is a horizontal hyperbola. A way to write the vertical one would be like this. So if y is positive, then it's vertical. If x is negative, again, vertical. So this one could be also written as x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. My question to you is, does it matter what a or b is in an ellipse? Yes, a will be the bigger one. Does it matter what a or b is in a hyperbola? No. What matters is which is positive, the x or the y. Okay. All right. Now this is the most important part of the day, that you understand how to differentiate between these three. If you can't do this, you won't do well on the test. I promise. Okay? It's just you have to understand this piece, or this test will be extremely difficult. What makes these equations unique compared to one another? What makes them different? What can you tell me? How are they similar? How are they different? the plus and minuses, okay? So let's focus on these two really quick. The only difference between them is one is positive, one is negative, correct? So in this situation for an ellipse, you end up with an x squared and a y squared. However, in a hyperbola, you have an x squared and a negative y squared, or you have a y squared and a negative x squared. Correct? What makes the parabolas different from those? One of them's not squared, correct? So in the first one, you have a y and then an x squared. And the other one, you have an x and you'll have a y squared. So parabolas only have one part that's squared, not both. Anybody have questions how we came up with that? Yes. Sure. Yeah. Take any of that. That's all notes. This is an example. Are you ready? Okay. This is it. All right. Place the following conic section into its standard form. You have to be able to do this on tests, okay? And you have to be able to do it efficiently. So you're going to practice over the next couple days. Graph the conic section and identify all important characteristics. That either makes an ellipse, a hyperbola, or a parabola. You tell me which one. Fran says hyperbola. She is correct. Why, Fran, did you say hyperbola? I have a positive x squared, and I have a negative y squared. And by identifying that, she understands that this then will fall into the shape of a hyperbola. So now I know the goal of the equation I'm trying to work with. Now look at your hyperbola. Can you see that you have two completed squares? Therefore, I'm going to complete the square twice in order to put it in that form. And so I'm going to write it out as follows. 9x squared minus 72x minus, parentheses, 16y squared plus 32y. Okay, factoring out that negative and making it a plus 32. Okay, now before I complete the square, what must I factor out of the first one? So I have 9 times x squared minus 8x Very good. Complete the square in the first one. 16. Take 8 divided by 2, get 4 squared, you get 16. I did not just add 16 to the left side. What did I truly add? Nine times 16, which is 144. So I will also add that to the other side. Because 9 times 16 is 144, that's what I need to add to the other side. Complete the square here. 1. I did not just add 1. What did I do? Negative 16. So therefore I need to subtract 16 over here. Have we practiced this before? Yes, we have. Okay. So I have 9 times the completed square, x minus 4 squared, minus 16 times what? Y plus 1, that quantity squared, equals, is it looking closer to the form that we want? The form we want is set equal to 1. So therefore we divide by 9 over 144. 16. 9. Done. Is that in its completed form? Yes. Now we need to sketch its graph and name all the important characteristics. Center. 4, -1. Okay, so I'm going to make a graph here, and I'm going to sketch this hyperbola on the graph. I'll begin by plotting its center. Its center is located at 4, -1, because the horizontal shift is 4, the vertical shift is -1. So 4, -1, that's the center. Very good. From there, I will create the box. First of all, is this hyperbola going to open up horizontally or vertically? Why? X is positive, so it'll open up horizontally. Very good. How many units is the box stretched in the horizontal direction? 4. So from this spot, I move over 4 to the right and 4 to the left. How many units is this box stretched vertically? 3. So I'm going to move up 3 and down 3. And from there, I can sketch my box. Once I have my box sketched, what can I draw through my box? What are they called? Asymptotes. My calculus class chastised me today. They said that on the Big Bang Theory, Sheldon calls them asymptotes, and that I'm stupid and he's smart. All right. Decide who you're going to trust, me or Sheldon. So, if this thing opens up horizontally, then it's at these points that we can draw the hyperbola. Those are the vertices. See how I wait till after I draw it to then describe it? It's easier that way. What are the vertices? What are the location of those endpoints? Remember, we need to go from the center. So we went 4 units this way. What's the location of that point? 0, -1. And then we went 4 units that way. 8, -1. That would be the mistake people make on the test. They simply write plus or minus 4 or 0. No. Length of the transverse axis. How far is it from vertex to vertex? 8. The foci, in order to find the foci, what do I have to solve for? C. A squared plus B squared is C squared. 9 plus 16, 25. So therefore C is 5. Do I move 5 units horizontally or vertically? Horizontally from the center. Everything is from the center. Somebody tell me the location of my foci. -1, -1 is correct. 9, -1 is correct. Asymptotes. Asymptotes are equations for lines, yes, no? Okay, so you might experience a little anxiety when I write this down, but trust me, this is the easier way, yes. Because plus or minus 4, 0 means that you're saying the coordinate is 4, 0 and negative 4, 0. Asymptotes. Y equals mx plus b, and y minus y1 equals m times x minus x1. Now, when you write an equation for a line, do you prefer to write it in slope-intercept form or point-slope form? Slope-intercept form. But we are going to use point-slope form because it's easier in this situation. Okay? Watch. In order to write an equation for a line, I need a point on the line, and I need slope. Once we do that, life will be very, very easy. A for the day, what is the point that both of the asymptotes pass through? The center, correct? 4, negative 1, which is the center. So our point is just the center. Then the slope. Slope of the box. What is the rise of the box? What is the run of the box? How much did we rise? 3. How much did we run? 4. 3 over 4, correct? One's positive, one's negative. So therefore, we can write the equation for two asymptotes very, very easily. Y minus y1, what's y1? So it'll be plus 1 equals, m is plus or minus 3/4 times x minus, what's x1? 4. Done. Leave it like that. Y plus 1 because y minus y1, if we subtract negative 1, we get a plus 1. Question? You're looking at my grid. These are 2 each. Over 2, over 4. Each tick mark is 2. So if you look, look at it this way. My rise for my box is 3. My run for my box is 4. Rise is whatever under the y. Run is whatever's under the x. Square root. Okay? Now, some of you may not like this. This is acceptable on the AP Calculus exam. So you don't have to put it back into slope-intercept form. Most things I'll demand you put in slope-intercept form, but right now, no. We're not testing on that. Just write it like this. Be quick and done. Okay? That's it. Okay, we'll see if we can get through this one. And that will be it. Pretend you didn't see my board. What shape is this one going to make? Why? Because one of them's not squared. One of them's not squared. So, is this going to be a y equals or an x equals? How come? Because x is squared. So we have x squared minus 4x equals 8y minus 28. What number do we add to complete the square? 4. X squared minus 4x plus 4. What does that factor down to? Equals 8y minus 24. I want to solve for y. What do I do to both sides? Add the 24. X minus 2 quantity squared plus 24 equals 8y. How do I solve for y? Do I divide the 24 by 8, the x minus 2, or both? Everything gets divided by 8. So what coefficient should I put out in front here then, to show that's being divided by 8? 1/8. 1/8 times the quantity x minus 2 squared plus 3 is equal to y. Is this open up and down or left and right? Up and down. Which one is it going to be? Up or down? Up because it's positive, so the direction will be up. And the vertex is 2, 3. It's whatever makes it 0. Whatever makes it 0. Okay? Yeah? Okay. So, describe the rest after you plot it. Okay? So, let's start to generate this graph. It looks like a 5 by 5 graph should be sufficient in this scenario. I could draw a perfect one today. Ooh, some people have faith in me, some do not. Emerald, what do you think? She says she's learned to be silent on these situations. All right, fair enough. I won't take it personally. Okay, I plot my vertex 2, 3. I know it's going up. If it's going up, what kind of line will divide this in half for the axis of symmetry? A vertical line or a horizontal line? A vertical line. Does a vertical line have an equation of x equals or y equals? X equals, very good. Now that we've drawn it, let's describe it. X equals what? 2. Say it with confidence. In order to determine these last 3, what value must I solve for? One over 4p equals a. That's all right. We've dealt with c in the past few days, so we just change it. A equals 1 over 4p. P is for parabola, right? I just made that up. So, okay, yeah, go ahead, use it. You get notes. You guys understand that. What is my a value? What is the coefficient in front? 1/8. 1 over 8 is then equal to 1 over 4p. We don't even need to cross multiply. You just look at that. What is the p value? 2. The focus sits on the inside of the parabola. So I move 2 units up or 2 units down. After I plot it, I describe the point. What is the location of that point? 2, 5. Is the directrix a point or a line? It is a line. Is it going to be horizontal or vertical? Horizontal. It is perpendicular to the axis of symmetry. If it's horizontal, is it x equals or y equals? Y equals what? 1. Length of the lattice rectum. Absolute value 4p. 8. Thank you. That means that we will move 4 units in each direction from the focus. I'll sketch it. And you guys will see my perfect parabola. That's pretty good. We'll pick a point. Any point should be equidistant from the focus and the directrix. I mean, come on. That's for all. Hanukkah. What? Thank you. All right. No, thank you. Here's the deal, folks. Okay, we don't have time to practice a lot of these problems because they take a long time, don't they? So here's your minimum. This is your bare minimum. Okay. 1, 6, and 11 on page 760 are already completed squares. The first one's an ellipse. Number 6 is a parabola. Number 11 is a hyperbola. So you're just graphing them as they are already shifted. But for 19, 21, 22, that's where you need to do what we just did. You need to complete the square and understand which form they take and what shape they'll have. That's the bare minimum. Tomorrow, I will put an additional 4 or 5 problems that if you get ahead of the game and you'd like to practice more, you sure can. This is the most important assignment for your test. Okay? So, we continue tomorrow. Ladies, we'll miss you. We'll upload the video. But all I'm going to do, girls, is just one example and add from there, okay? All right.